Alright, so we're going to approximate the area under a curve from x equal -1 to x equal 2, and the curve is 1 plus x squared. And we're wanting to use 3 rectangles and left endpoints. Okay, so the first thing we want to do is just kind of do a quick sketch of the graph. Well, the graph of 1 plus x squared, well, we know x squared is a parabola, and it's going to be shifted up 1 unit, so it's going to look something like this. And we're going from -1 to 2. So let's just say we've got -1 here, here we've got 1, and here we have 2. And we are looking for this area here. Alright, so we know we want to use 3 rectangles. So we're going to break this up into 3 even rectangles. And they're 1 unit apart, so first let's see how we get that where they're 1 unit apart. Well, we can find delta x, which delta x is going to represent the width of the rectangle. So the way we find that is we need the length of the interval, so that's going to be this value here, 2, which is here, minus this value, -1. Okay, so we've got 2 minus -1 over the number of rectangles we have. So the number of rectangles we have is 3, and so this is going to be 3 over 3, which equals 1. So you can see the width of each one of these rectangles here is 1. Okay, each one of them, this is -1 to 0, 0 to 1, and 1 to 2. Alright, so what we have to do is we have to draw rectangles. Now we can draw the rectangles any way we want, but they're wanting us to use left endpoints. So when we draw the rectangles, we're going to come here to the left endpoint like this, and there's your rectangles with left endpoints. You can do right endpoints, you can do midpoints. I've got another video working this problem with right endpoints, and I'll have another one working it with midpoints. You can check those out. Alright, so basically what we're doing is we're finding the area of each one of these rectangles here, okay, and then we're just going to add up those areas. Alright, so the area of the rectangle is the width times the height of the rectangle, or length times width, however you want to look at it. Well, we know the width of each of the rectangle is 1, but now we need the height. So how do we get the height of this rectangle here? Well, that's the value from here to here, this y value. Okay, see, if we can calculate this y value here, see, this is the point -1 and then some y value. Well, how do you get that? Well, you plug this -1 in to the function, and that gives you the y value, which would give us the height of the rectangle. Okay, so let's calculate f of -1. So f of -1 is equal to 1 plus -1 squared, which that's 1 plus 1 is 2. Okay, so that's the height of this rectangle. And then we're going to need the height of this rectangle. Let me highlight this rectangle here in yellow, and then let's highlight this one in green so you can see it, and then we'll highlight this one in purple, magenta color. So these are our 3 rectangles. Okay, so now looking at this rectangle, we need this height here. Well, if we plug 0 in, that'll give us this y value here. So we have f of 0 is equal to 1 plus 0 squared, and that's 1. and then we need the height of this rectangle. So if we evaluate at 1, see there? If we plug 1 in, that'll give us this y value, which will be the height of that rectangle. So f of 1 is equal to 1 plus 1 squared, and that's going to give us 2. So now we can calculate the area. Well, the area, okay, so let's find the area of this first rectangle. So it's the width, which is 1, times the height, which we calculated here to be 2, all right, plus the area of this rectangle. Well, the width is 1, and then times the height. Well, we plug 0 in to get the height, so that height is 1, plus the width of this rectangle, which is 1, times the height. Well, when we plugged 1 in for the function, that gave us the height, so that's 2. And so that's 2 plus 1 is 3, plus 2 is 5. So this area here is 5. All right. And you know, the more rectangles you use, the more accurate the area is going to be. So I hope this video helped. Check out my other videos. Give me a like, share, and subscribe, and thanks for watching.